Hello, calculus fans. Let's take this equation, rho sine phi equals 2. That's an equation that's in cylindrical coordinates, and let's convert it into a rectangular equation. And in doing so, we'll be able to describe what kind of object this is, what kind of surface. What we'll do is convert directly to rectangular coordinates. First, let's square both sides to get this. Rho squared sine squared phi equals 4. Now, I'd like to employ a trick. Now, mathematicians use lots of tricks. When you see a trick for the first time, it looks strange and mysterious. But I want to make sure it's clear that when you take a trick and you start using it more than once, it's no longer a trick. Now it's a method. And we want that to be a standard part of our toolbox. So the trick that we're going to employ here is that we're going to add rho squared cosine squared phi to both sides. And this does look mysterious. Why would you do that? So here's the equation we're starting with. Rho squared sine squared phi equals 4. Now we're employing our trick. We're adding rho squared cosine squared phi to both sides. Now you should start to see some of the idea of what's going on here. See, on the left side, we can factor out rho squared, and then what's left over, this sine squared phi plus cosine squared phi, well, that's just 1. All right, that's nice. We have cleaned that up just a little bit. We also know something about this, rho cosine phi. That's an identity. That's an identity when converting rectangular to spherical coordinates. Okay, so first we get rid of the sine squared phi plus cosine squared phi. That turns into 1. And now there's two things that happen here. First of all, rho cosine phi turns into z. And then on the left-hand side, rho squared turns into x squared plus y squared plus z squared. See, at this point, as we're meandering our way through simplifying this equation, we're just employing a lot of the conversion formulas between rectangular and spherical coordinates. Okay, so now we've got x squared plus y squared plus z squared equals 4 plus z squared. Aha! Well, we'll just cancel. And we are left with x squared plus y squared equals 4. Now that's a very simple looking equation. Now, back in the good old days, you would have said that this was a circle with radius 2, but not so in 3 dimensions. This is a circular cylinder with radius 2 centered along the z-axis. Here's a picture of that cylinder centered along the z-axis, radius 2. Okay, that's all for now.